Now we are getting into a very interesting part, representing real life situation with whatever we have learned. And now you will appreciate how this algebra helps you to understand the situation, right? So let's review what you already know about lines first. A straight line, as shown here in green color, represents a linear relation. Linear because it is a straight line. Relation between two variables, one dependent on the other. Independent variable is normally on the horizontal x-axis and by default it is x. Dependent variable is along the vertical axis and by default it is y. So a relation between y and x, if it can be graphed as a straight line, we say that this relation is linear. So that's first thing to understand. A linear relation can always be represented as a straight line on the graph. Now, second part you learned is what can be the equation of this linear relation. Equation means equating dependent variable with independent variable. Now, dependent variable is y for us, and you learn y equals to mx plus b, right? Ask anyone. Everyone knows y equals to mx plus b. Now, that is what we know, right? Y equals to mx plus b. What is m and what is b? In this equation, y equals to mx plus b, let me underline this equation. M is the slope of the line and b is the y-intercept. Y-intercept because line crosses y-axis at this point. Therefore, we call it y-intercept. So b is y-intercept, a point on the graph where it crosses vertical y-axis. So at that point, value of x is 0. If I put 0 here, x 0, I get y equals to b. So y value is b. So at y-intercept, x value is 0 and y value is b. Thing to remember. Now what is slope? Slope, as you know, is rise over run. Change in vertical divided by change in horizontal distance, right? So delta y represents change in y value. Delta x represents change in x value. So if there are 2 points P and Q, any 2 points on a straight line, let us say coordinates of point P are x1, y1 and that of Q are x2, y2, then slope is change in y over change in x, y2 minus y1 divided by x2 minus x1. That gives us the slope. Now, if the line is moving upwards as you go right, then the slope is positive. If the line is going downwards, then the slope is negative. Right? Going down the hill, negative slope. But if the line is horizontal, then there is no change in y and therefore the slope is 0. So the slope is 0 for a horizontal line. If the slope is 0, the equation will be y equals to b. It will just be a straight line. Y value will be b everywhere, all along x. Very important thing to remember. One more thing I want to add here, make a note. This equation cannot be used to write equation for a vertical line. If I write a vertical line, so let me draw a kind of vertical line here. Let us say a line like this, right? I'm showing it in dotted line because we cannot represent this line with this equation. Reason is rise over run. if you try to make a triangle here on a vertical line, taking any 2 points, you get change in y, but change in x is 0. Do you see? There is no change in x. X position is same. Therefore, change in y divided by change in x will be something divided by 0. Since you cannot divide by 0, it is undefined. So vertical line is m is undefined. Remember, right? So m is undefined. So we cannot write equation y equals to mx plus b, right? Well, if this point is a, then we can always write x is equals to a in such a situation. But we cannot write y equals to what, right? Because y value at this point a could be anything. Is no fixed value. That is why we cannot write y equals to what. That gives you a very good overview of linear relations, understanding of our equation y equals to mx plus b, and also knowing that a straight line represents linear relation on a graph which relates dependent variable y to the independent variable x, and the equation between them is always y equals to mx plus b. That is going backwards, right? The whole thing. So this is all what we know. And what are we getting into? We are getting into rate of change. Now, since slope is a ratio of change in y, what is slope? M, change in y to change in x. It can be interpreted as the rate of change of y with respect to x. I would like you to copy these words. Remember, understand. Since slope is the ratio of change in y to the change in x, it can be interpreted as the rate of change of y with respect to x. So slope is rate of change. So whenever you have a linear relation, in that case, slope is rate of change. Do you understand? So therefore, I can write down my new equation, which is y equals to rate of change. I'm writing rate of change times variable x, right? This variable x plus b. So that is my application. That is how rate of change is related. When we have a linear relation, correct? And it is extremely important. We see it so many times. Let us say somebody is drawing a salary of some fixed amount, let's say $500 per week, and the person gets commission on sales, let's say 10%. Then with every sales, salary increases. So the rate of change is the commission rate, and the fixed salary drawn is B. And so you get your equation. Do you see? So the take-home salary will be rate of change, that means 10% of sales plus fixed amount. Let us say a person is walking away from home and the person is already 100 meters away and the walking speed is 5 meters per second. In that case, the equation will be rate of change is 5 meters per second. So we'll get y equals to 5x plus 100 meters away plus 100. So we get another equation. You see that? Let's say from top of a building you release a balloon and the building is 25 meters high. If the building is 25 meters high, value of b will be 25, and if the balloon rises 2 meters every second, then rate of change will be 2, and we get our equation y equals to 2x plus 25. Are you understanding the importance of this? It has huge applications, and in videos to follow we will explore them one by one. So first set of videos will give you the graph and ask you different questions, including to write down the equation. Next set of videos will give you the equation and make you draw the graph, and then we'll mix and match. And I have a small quiz later. I hope you enjoy all this in this set, and that will be very useful for you from grade 9 onwards. So these videos are targeted for grade 9 students, and they will be helpful to you even afterwards. Even grade 12 students will appreciate what they have learned here. Thank you and all the best. I hope you enjoy the journey with me.